Okay, we're in a new unit, Unit 5, Cycle 1. Remember, acquire just means notes, and this unit is all about what's called quadratic functions. We're doing something a little bit different with our notes this semester. And what that little piece is the learning target, or LT. Our learning target says what we're going to do for those sets of notes, so that when you get to the end of the notes, you think, do I know how to do that, or do I not? You can come back to your learning target, read through it, and say, yep, good to go. Our learning target for today is I can identify key features of a quadratic function, and that includes the vertex, the max and the min, the zeros, the x-intercept, the y-intercept, and what's called the AOS. So I want you to go ahead and pause the video right here, copy down your learning target, and when you're done, you can pick back up. Okay, hopefully you've written down your learning target. We're going to jump right into the notes. So when you're taking notes, you should take notes to the best of your ability. If that's using colors or highlighters, circling, boxing, writing things on the side, do it. These are your notes. Very first thing, a quadratic. It's a funky word. Is a function of the form f of x, remember this just means y, equals ax squared plus bx plus c. And what this basically means is that the biggest exponent is x squared. No matter where it is in here, the biggest one that we have will be a square. Our key features are these right here that you notice we put in our learning target. Minimum, we can write just as min. Maximum, we can write as max. And the axis of symmetry, we shorten to AOS because that is a lot to write. So, we're going to use these features and we're actually going to plot them and label them on our graph below. So, before we do that, we have what's called an X-intercept. That's where it crosses the x-axis, but we use other words for that. So the other words for X-intercept are solution, root, like a flower has roots, and zero. So, using these words, we're going to see if we can define where they are on these graphs. And we have two graphs, one that opens up and one that opens down. So let's start at the one on the left. This point right here is what we call the vertex. And this is also the lowest point on our graph. Let's see if we can make that a little clearer. It's the lowest point on our graph. So we're also going to call this the minimum. The vertex is either the highest point or the lowest point. And if it's the lowest point, it's called the minimum point on our graph. Over here, we have our y-intercept. It crosses our y-axis. Now, one of our new words is the axis of symmetry. So I'm going to take a different color, and I'm going to draw this line right through the center of my graph. This red line right here is our axis of symmetry. So what that means is if we split our graph right down the middle, it is symmetrical on both sides. Symmetrical means the same. So this side looks exactly like this side. Our axis of symmetry is always going to go through our vertex. Okay? Now let's look over here at this one. If you notice, I didn't label any x-intercepts on this one. This is our x-axis. Our graph never touched the x-axis, so we don't have any x-intercepts. On this one over here, you'll notice that this point right here is our vertex. It's the highest or the lowest point. This one happens to be the highest. So you guessed it, we are going to call it the maximum. Now, on this one, we do have some x-intercepts and y-intercepts. Our y-intercept is right here. It's crossing the y-axis. I'll zoom in a little bit so you can see. Now, we do have some x-intercepts, and I'm going to mark them with a different color. If You have a highlighter, or you can just mark them with your pencil, doesn't matter. These two, I'm going to draw some arrows, are our X-intercepts. Now remember, we said we could call these solutions. We could call them roots. We could call them zeros. There are plenty of words that the STAR test and that we use in class that mean X-intercept. And that simply means they cross our x-axis. So let's do one more thing. We've got to do our axis of symmetry. Remember, our axis of symmetry goes through our vertex. So here is our axis of symmetry. Splits our graph in half. Okay, right now all we've done is label. We haven't put any points, we haven't put the numbers with it. So let's flip to our next page and see what we can work on having to do with numbers. So, for example, number 1. The question says, determine how many solutions would exist for each quadratic function below. Now it says solutions. We know solutions means X-intercept. So for this first one, my graph crosses the x-axis twice. So we're going to have 2 solutions. The next one, it crosses once. We've got 1 solution. That's okay. This one, does it cross at all? Nope. It does not cross our x-axis. This one, we've got just 1 time it crosses or touches. We've got 0 times on this one. And this very last one, it does cross twice. So it does not matter if it's up or down. It can cross or touch our x-axis. So now with example number 2, we're actually going to be labeling these points and not just putting dots where they are. So remember, our vertex is the highest or lowest point. So I've got a lowest point right here. And our vertex point, if we start at 0, 0, is -3, -2. Okay, our min or max is where our vertex is. This is the lowest point on our graph, so it is the min, and it is the same as our vertex. Ooh, solution. Remember, solution means x-intercept. So I'm going to write x-intercept above this, and that could be more than 1 sometimes. We're going to look over at our graph. I have 2 places where it crosses the x-intercept, or the x-axis. We've got -1, 0, and we've got -5, 0. Looking good. Our next one is our y-intercept. That's going to be up here, and we're just going to guesstimate. So we don't know the exact point. It's kind of in the middle of 2 numbers. So we're going to say first 0, and then it goes up to about 2.5. So I'm going to say 2.5. Okay, and then our axis of symmetry, remember that goes through the vertex. So our axis of symmetry goes through the vertex. I'm going to draw it with a dashed line, because it's not really a line, it's just, we're pretending that's where if we could fold it, it would be symmetrical. The axis of symmetry is a vertical line. So you're going to think of VUX. This is a vertical line. VUX is the word we go to, which means x equals a number is our equation. So I'm going to say x equals, and the x value we have, it goes through -3. Now, if you notice, it goes through our vertex. So our axis of symmetry is just really our x value from our vertex. Crazy. Now, this piece right below that says a parabola, fancy new word, is the name of the shape that a quadratic function makes. So this shape that it makes is called a parabola. And remember, it can go up like these examples right here, or it can go down. For example number 3, find the following key features on the following quadratic function. So this is a table. We're not given a picture. We could graph it, but we don't have a graph right here. So I'm just going to look at the table and see what I can find that might help me figure out these things. So I've got -3, -2, -1, 0. Am I missing 1? 1 might be helpful. 2, 3, 4, 5 might be helpful. So I'm going to make a table to the side, and I'm going to add in some of the things that we're missing. So I'm just going to start labeling. -3, -2, -1, 0. I'm going to add in 1, 2, 3, 4, 5, 6. So I added in, we were missing an x value of 1 and an x value of 5. So I'm just going to fill these in for what I know so far. Oh, I don't know that one yet. Pause. Leave that one blank. For 2, it's -2, 0, 6, I don't know 5, and then 30. So right now, I'm kind of looking, and I've got some matching things. I've got 2 30s. I've got 2 6s. I'm wondering if this is a pattern. Well, I want you to look over here at this picture of our graph. If you notice, we always have 2 points that are the same. So we've got one over here at 0. We've got another at 0 for x for y values. We've got one right here at -1.5. We've got another one at -1.5. And we've got something in the middle that's all by itself. So we're looking for the pattern that's got something in the middle, and then on the other sides, it's a pattern. So I've got 2 30s. That probably means 5 is going to be 16. So I've got 30 and 30, got 16, 16, 6 and 6, something in 0, and then I've got a -2. So I'm going to go ahead and say that 1 is probably going to be a 0. So these are the 2 that we had to fill in with our own knowledge. Okay, so I've got this pattern, 30, 30, 16, 16, 6, 6, 0, 0, -2 is smack dab in the middle. So that is going to be our vertex. Our vertex is the one that is all by itself in the middle. It doesn't match with anything. It's in the middle. Remember, vertex means min or max. Now, if we look at this, we have to see if it's the lowest number or the highest number. Is -2 the lowest or the highest number in our y values? It's the lowest number, so it is going to be the minimum. Because our graph is going to go up higher than this -2. So it's the same as our vertex. Now, root. Root means x-intercept. So we're looking for x-intercepts. And let's recall that x-intercepts look like number, comma, 0. I'm looking for anywhere in here where I see a number, comma, 0. I've got a 0 here, and I've got one here. So our x-intercept is going to be 1, comma, 0, and 3, comma, 0. Let's recall our y-intercept. Y-intercept is just the flip of that. It is 0, comma, number. So as I look through this table, I'm looking for a 0 on the x side, number on the y side. I find 0, comma, 6. And lastly, for our axis of symmetry, we can't just draw it in the picture. Remember what I said over here, it goes through the vertex. So we know that the axis of symmetry is VUX. It's a vertical line. It's x equals a number for our equation. I'm going to write x equals, and it is the x value of our vertex. So we go back up here to the vertex, x equals 2. Now if you need to watch those again or try them again on your own and then check, do that. These are two ways that you can use a graph and a table to figure out all of the key features. Let's go to the last page of our notes. Now, these are some questions that have been on the STAR test before. So we're going to take these and get some practice so that when you get to the STAR test, if they look the same, awesome. For example, number 4, 2 points of a quadratic function are shown below on the graph. What is the equation of the axis of symmetry of this quadratic function? Well, we know that symmetry means same on both sides. I have 2 points on the same y value. That means if I were to fold over my graph wherever I fold, this point should match. So if these are the same on both sides, I need to find the center for it to be the axis of symmetry. So I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8. There's 8 units in between, which means the center is going to be right here, 4 units from each of them. So I've drawn the axis of symmetry, but now I need to write it out. Remember, it's a vertical line, so we think of VUX. X equals a number is our equation. So my axis of symmetry is x equals, and it is on 2. That's it. So I want you to try number 5, and then check it when you finish. Okay, we're back on number 5. Hopefully you tried this. Hopefully you got the axis of symmetry was x equals -1. There were 12 units in between. The middle was 6 units from each, which made it -1. Okay, we'll do number 6. This one says, a design student is drawing the graph of an arch. As shown, the arch has the shape of a parabola. Remember, that's just a fancy word to say what the shape looks like. That begins at the origin and has a vertex of 6.4, 14.2. Other than at the origin, so right here, at which point will the graph intersect the x-axis? So, if you would not learn how to do this yet, you might say, okay, maybe I just finished drawing and I see where it gets me. Oh, right about here. I think I'm going to choose this number right here. That's a good way to guess if you're not sure, but let's do it with math. So first thing I'm going to do is it tells me my vertex. I'm going to come up here and I'm going to label, this is 6.4, 14.2. That is my vertex. Okay, it says other than at the origin, at which point will it intersect the x-axis? Well, we know that the axis of symmetry goes right through our vertex. So I'm going to go ahead and draw my axis of symmetry. Remember, that tells me it's the same on both sides. So if there's one that touches the x-axis right here, that means on the other side, the same distance away, the other one will touch the x-axis. So let's just count and see. We know that this right here is 6.4 units. That's what our vertex was. We went over 6.4 units from 0. So that means if I go over 6.4 more units, it's exactly the same on both sides. I should find my other x-intercept. So if I take 6.4 and I add 6.4, I get 12.8. So if I had just made a crazy drawing, I'm over here at 13 point something. But really, it should go right there. So my point that I would cross at would be 12.8, 0. That's how we use the axis of symmetry to get the equal points on both sides. Last question, people. We can do it. Okay. Example number 7. What are the possible values when the function is equal to 8? So, right now, all it says is when the function is equal to 8. When you see the word function, I want you to think of f of x. Okay? Function is f of x. That means function. over here it says function equals 8. That's true. The function is equal to 8. Well, what do we know that f of x also stands for? It stands for y. So that means y equals 8. So I am just going to look on my graph to see where 8 is. So here's my y-axis. This is where 8 is at. And it wants me to find the possible values on our graph when y is equal to 8. I'm going to go over here. This is where y equals 8. This is where y equals 8. And I'm going to find those 2 points. So I went over 5 and up 8, and then I went backwards. So -3 up 8. And those are the 2 values, 5 and -3, where my y value is 8, or my function is equal to 8. Okay, so some of those are star questions. You can do this. We're also adding a summary into our notes this time for this semester. And what a summary is to take what we've learned in these notes and kind of write a little remember at the end. So if we had to summarize all the notes, or if we had to pull out some important pieces, what would we put? Today I'm going to help you with the summary because it's new, and I'm going to write a few things that will help us. So remember that X-Intercept can also be solution, fruit, or 0. Okay? Remember that the vertex is the maximum or the minimum. It depends on if it's the biggest point or the highest point or the lowest point. And remember that the axis of symmetry goes through the vertex. And then the way we write it is x equals a number. Those are the 3 big important things that we had from our notes today. Go ahead and get started on your practice. If you have any questions, please do not hesitate to ask your teacher. Good luck!